Hello everyone, here are the solutions to the worksheet that you had to fill in all of the exact values of the 6 trig functions, as well as any missing degrees or radians. Pause the video to thoroughly look this over, check and correct your results. Notice what I have highlighted here: cosine theta, secant theta, those are all reciprocals. Sine theta, cosecant theta, those are reciprocals. Tangent and cotangent, those are reciprocals. And hopefully, if you also noticed, like going through the 30 degrees of pi over 6 family, look at pi over 6, look at 5 pi over 6, look at 11 pi over 6, 7 pi over 6. If you go across those rows, all of the values are going to be the same, except depending on the quadrant you're in, the signs could vary. So like I said, if you need more time, pause the video to look this over. Let me know if you have any questions. All right, today we're switching from trigonometry to something that you should have seen at the end of Algebra 2, but maybe you guys didn't get there last year. We're going to take a look at logarithms. Logarithms are connected to exponents. A lot of math books just come right out and say logarithms are exponents. But we're going to take a look and graph their functions. So a logarithmic function is actually the inverse function of an exponential function. So what I'd like for you guys to do is to go to Desmos and write these 3 equations down. I want you to graph y equals 2 to the x. Now this is a logarithmic function right here. This is red. Log base 2, this little subscript here is 2, of x. So log base 2 of x. I want you to graph that as well. And then graph the line y equals x. Okay, so just showing you at first, here is the exponential function y equals 2 to the x. Again, under functions, you should be able to see the log. So I'm going to do y equals. So if you hit the functions, it's right here under miscellaneous. We have log base a, so you want to select that. Now notice where the cursor is down here at the bottom of the G. So you want to hit 2, and then in the parentheses, we want to type in x. And then to show that these are inverses, just type in the equation y equals x. Oops. I want to go to a new line below that. And you can see that they reflect. Notice here we've got we'll say here 4, 2, and then here we would have 2, 4. Right there. We could type those in as well, but we would have 4, 2, and 2, 4. So those would reflect over the line y equals x. So a logarithmic function and an exponential function are inverses of each other. All right, so 2 things we're going to do today. We're going to take a look at how to go from logarithmic form to exponential form and vice versa. And we'll also take a look at 3 basic properties of logarithms. Okay, so exponential form, I'm just going to use variables here to represent any base, exponent, and number. So if we have some base b raised to some power p, that's going to equal some number n. Logarithmic form starts with a log. The base, as over here, the base is b, so the base goes right here. It's a little subscript of the logarithm. Log base b of a certain number n is going to equal the power p. So this is how we rewrite it. So if we have some base raised to a power, that's going to equal some number. Rewriting it as a logarithm, we have log base b of that number is going to be that power. So with today's post, I attached 2 worksheets. I want you guys to take a look at the first one, had the task 7.1. This is to convert between logs and exponential functions. We're going to do some examples off of that. I have the problems recopied. We're going to do some of the odds, and then your assignment will be to do all of the evens. So this is off of the first worksheet. At the very top says Algebra 2, Task 7.1, convert between logs and exponential functions. On the first side, the directions tell us to rewrite each equation in exponential form. So they're given to us as a logarithm. So go ahead and copy down number 1. So when we go to rewrite this as an exponential equation, we're just going to have some base b raised to the power p is going to equal the number n. So our base here is always going to be, as a logarithm, is always going to be that small number right at the lower part of the g. So exponentially, we'll get 16. The power of a logarithm is always on the other side of the equal sign. So it's 16 squared is equal to 256. And that makes sense. 16 squared is 256. If we got this reversed, we would maybe think 16 to the 256 power is 2. No. So this is how we're looking at it. Sometimes there's numbers, other times there's going to be variables. Let's jump down to number 9. If you want to give this a try, feel free to. Our base here is 9. The power would be the -2. And then the number is what's after the log here, so we have 1 over 81. And is this true? Is 9 to the -2nd 1 over 81? Yes, because 9 to the -2nd becomes 1 over 9 squared, which is 1 over 81. Let's take a look at number 15. I have some variables here, but the process is the same. Again, if you want to try rewriting this on your own, you can. All right, so our base here is the y, our exponent is the x, and the answer is 41. And there's no way to really check this or make sense of it because we don't have actual numbers to show here. Now for 17, notice there is no number here with the base. So when a base doesn't show up, it's always going to be a 10. So if we just have log but no base is indicated, it's always going to be a base 10. So here our base is 10. Our exponent would be the y, and then that would equal x. So 10 to the y, power of y is going to equal x. Now on the back, the second side of this worksheet, we're going to do this in reverse. We're given exponential equations and we want to write as a logarithm. So we always start with a log. Go ahead and copy down number 21. We're going to start with log. What's our base over here? The 4, so we put a little 4 here. The number is what goes next, the answer really to this, so it's going to be of 2. So log base 4 of 2 is going to equal 1/2. You guys go ahead and try 29. So here we're going to have log, our base is 6 of 216 is going to equal 3. And go ahead and try 35. Here our log is x, so we have log base x of 91 is going to equal y. So that's how we go from exponential form to logarithmic form, or in the first set of problems from logarithmic form to exponential form. So now let's go ahead and take a look at properties of exponents. There's 3 properties of exponents, or logarithms. And I say exponents because there's 3 properties of exponents as well. So these properties are going to sound a little familiar once we talk about them. So properties of logarithms. The first one is if we have a log of any base, b, of a product, m times n, we can expand this, and that's essentially what we're doing. We're going to look at something that's written as a single logarithm, and we're trying to expand it, or something will be expanded, an expression will be expanded, and we're trying to condense to a single logarithm. So what I'm giving you right now, that's a single logarithm. If I wanted to expand this, this becomes log base b of m plus log base b of n. And think of exponents. When we multiply powers with the same base, we add the exponents. So multiplication and addition are connected. Second property, if we have log base b of a quotient or a fraction, this becomes log base b of m. Now keep in mind when we divide powers, with the same base, we subtract the exponent. So we're going to subtract log base b of m minus log base b of n. Whatever's in the denominator gets a minus sign in front of it. And then the third property is log base b of m raised to the nth power. If you remember, if we have a power to a power, we multiply the exponent. So this exponent comes down in front, and we multiply it by log base b of m. So those are going to be our three basic properties, and that's all we're looking at today, just some basic examples of applying these properties. So now we're going to go to the second worksheet, properties of logarithms. On the first side, we're asked to expand each logarithm. We don't want an actual value. We just want to expand using the properties. So go ahead and copy down number 1. So this is log base 10, so we don't have to write the 10. I'm multiplying, so this can also be written or expanded as log base 10 of 6 plus log base 10 of 11. Or just log 6 plus log 11. Now eventually, if we were to do more with these, they do serve a purpose. A lot of times they're irrational numbers. So working with these properties can help us get to an answer, solve an equation. Eventually logs will be involved with equations. A lot of exponential growth and decay involve logarithms as well. And knowing these properties helps us solve those equations. Now, there's nothing else we could do with number 1. Number 5. Technically, first we see a fraction or a quotient. So let's separate this. This means we would have log base 10 of 2 to the 4th, and then we would subtract, since the 5's on the bottom, minus log of 5. Now, with this first term, we can still go a little bit further. So that power of 4 will come down in front. That's that third property. So we'll get 4 times log base 10 of 2 minus log base 10 of 5. You guys go ahead and try number 7. All right, so let's see what you were coming up with. Pause the video if you need more time. We're still dividing here, so we would have log x minus log of y to the 6th. Log x, there's nothing else we could do with it, but the second one, the 6, can come down in front. So we would have log x minus 6 log y. Now number 11 we're going to do together. What I'm first going to do with this is rewrite this as log of x, y, z. When we take the cube root of something, it's like raising it to the 1/3. So now what I'm going to do is write this as log, and each of these bases or factors are going to get raised to the 1/3. So it's log of x to the 1/3 times y to the 1/3 times z to the 1/3. This is just one way to show this. So now I'm multiplying all of these, so it becomes log x to the 1/3 plus log y to the 1/3 plus log z to the 1/3. And then finally the 1/3 is going to come down in front of each term. So we have 1/3 log x plus 1/3 log y plus 1/3 log z. So we could have done it this way, or we could have just put the 1/3 down in front here. And then this would become 1/3 times log x plus log y plus log z. And then if we distributed the 1/3, we would have got that final result. So there are a couple ways to do that. All right, so now on the back, we want to condense each expression to a single logarithm. So we're just doing the reverse process here. So I'm going to copy down number 17. So what I first notice here is I'm subtracting. So I'm going to write a single logarithm, and subtraction means a fraction. What's going to go in the numerator? Anything that has a positive sign in front of it, so the 7. Now technically what I could do here is rewrite this as log 7, and then this 2 becomes the exponent here, so then this is log 12 squared. So then I would have 12 squared go in the denominator. Yes, technically you could write that as a 144, but we don't have to. Number 19, let's start the same way. If we see any numbers out in front, let's turn them into the exponents. So we get log base 3 of u to the 6th plus log base 3 of v to the 6th. So now as a single logarithm, now I have a base 3. If I'm adding, what am I going to do with the u to the 6th and v to the 6th? We're going to multiply them. So it becomes log base 3 of u to the 6th times v to the 6th. So we could leave it like that. Or we could say it's log base 3 of uv to the 6th this way, if you wanted to. So this last one, it is under critical thinking questions, but I wanted to go over something a little bit more challenging. Go ahead and copy this down. What we could first do here is distribute this 2, so we could show 2 log 2x minus 2 log y, and then distribute this minus sign, so then minus log 3 minus 2 log 5. Now technically, if you're wondering, this 2x should really be in parentheses. So now any numbers out in front, I want to turn them into exponents. So now this becomes log of 2x squared minus log of y squared minus log 3 just stays there, and then this becomes minus log 5 squared. So to write this as a single logarithm, I'm going to go ahead and do this now. I do see some subtraction here, so that means I'm going to have a fraction. Now anything that's positive is going to go up top, so the 2x squared will go up top. Anything with the minus sign in front of it is going to go on the bottom. I'm going to put the numbers first, so this is really 3 times 5 squared times y squared. Technically, we could leave it like that, or we could really say it's log of 4x squared up top. That's 3 times 25, so we get 75y squared. So there was our little lesson over the basics of properties of logarithms and how to go from logarithmic form to exponential form and back. So your assignment today and tomorrow is to do all of the evens off of these two worksheets. Let me know as you're working on this if you have any questions.